Let's go ahead and get going here. Hey, today we're dealing with characteristics of quadratic functions, and some of these things we've already talked about, but we want to make sure that we're clear on them. So, properties of the graph of a quadratic. This stuff's in your student journal as well, but it'd be good to take some good notes on graphing today. So if you want to follow along in your student journal, the core concepts in there. But properties of the graph of a quadratic. F of x equals ax squared plus bx plus c. Okay, we studied this in algebra. The number attached to your x squared is a, attached to your x is b, and attached to your constant is called c. Okay. To find the vertex, the x value of the vertex, and also to find the axis of symmetry, which we're going to call AOS, that's how I'll reference it, axis of symmetry, the equation is x equals the opposite of b over 2a. So how many of you remember that from algebra? Okay, the opposite of b over 2a means we take, in standard form, ax squared plus bx plus c, we take the opposite of our b term and divide it by twice our a term. And that tells you the x value of your vertex. So if I was looking at this vertex here, the opposite of b over 2a gives me the x value. The y value you have to calculate by throwing it back into your equation. So once I know x, I can plug it in and find y. Okay, the opposite of b over 2a also gives you this axis of symmetry, which is the same as your x value. Okay? Alright, now this gives a lot of mathese behind it. It says the parabola opens up when a is positive, or a is greater than 0. So once again, if a is positive, same a that we've been dealing with our vertical shifts. Okay? It opens down if a is negative. Same a we've been dealing with our vertical shifts. The graph is narrower when a is further from 1, and it's wider as a approaches 1. Okay? Or, excuse me, when it approaches 0. And then the axis of symmetry. And then you have this thing right here. You're like, what in the world? Well, that just means you plug in that for x into your equation. Okay? So this is us speaking math about it. The y-intercept is always our c term. Okay? That is what all that says. So we're trying to decipher what the math says here. So you want to be able to read math. Okay, so let's try to apply some of this. Here's some graphs we're going to go through. And we're actually going to do 1 and 2 together, or 1 and 2 first. Okay? And on number 1, let's go ahead and take one of our grids. It's nice when things are in vertex form. Remember, vertex form is the form of y equals a times x minus h squared plus k. Now, I didn't put anything with the horizontal stuff in there. Okay? But that's a times x minus h plus k. This h right here, that h and that k, that represents our vertex. That's why we like vertex form. So when I look at this, if I look at it and go, hey, dude, that's vertex form. This right here, I like to think when I'm trying to find out h, some students just look at it and go, well, it's opposite. It has to say minus h, and that says plus. So therefore, my h value, or my x value of my vertex is negative 1. I like to think of it as what will make the inside of this parenthesis 0. Okay, and it's negative 1. That tells you what your x value of your vertex is. What am I adding to this function? Nothing. My k value is 0. That means my vertex is at negative 1, 0. Now let me pause for a minute. Any questions there? So we've talked about 2 forms already today. Tell your neighbor what those 2 forms are. Okay. Standard form. Vertex and standard form. Vertex tells us the vertex standard form doesn't help us out as much right now. But it will. Okay? So, if we're graphing this, going through and graphing it, try to put a grid next to it. You guys tell me if it doesn't show, but we go to negative 1, 0. Okay? We know this graph should just slide over 1. Is it a parent function? Is it the same width? No, it's a vertical stretch, opening down. Okay? So we know the negative tells us it opens down, and remember that 3, this number, that's our A term right there. It'll just tell us if we go over 1, we go down 3. Now that's if there's no other kind of shifts going on. If you're not sure on that, then you can always just plug in the next value. If I put, like, there's negative 1, go to 0. If I put 0 in here, 0 plus 1 is 1. 1 squared is 1 times negative 3 is negative 3. That's my output. When I input negative 2 plus 1 is negative 1 squared is 1 times negative 3 is negative 3. I want you to find the next value. So find out what y is when x is 1, and find out what y is when x is negative 3. Okay, 1 and negative 3. Okay? Okay, so at 1, 1 plus 1 is 2. 2 squared is 4 times negative 3 is negative 12. So that would be 11 and 12. So if I go off my graph, I better label that 1, negative 12. Okay, which means if I reflect that, I should get the same value over here. Remember, across your axis of symmetry, which is right here. Oops, I put that in the wrong spot, didn't I? There we go. Across your axis of symmetry, it should be a reflection. Okay, so that would be negative 3, negative 12. Okay, so it says label our axis of symmetry. Axis of symmetry is x equals negative 1. Right? That's an equation of a line, so make sure you label that. Don't just put negative 1, because there's 2 negative 1s on this graph. There's this one at x, and then there's the one at y. So axis of symmetry is negative 1, and then it says label our vertex. Our vertex is at negative 1, 0. Okay, that is vertex form. Not too bad, right? Okay. Tell your neighbor your vertex for number 2. We're not going to graph it. Just tell them where the vertex is. Okay, vertex is at 2, 5. Yes, it's what makes this 0 for x, 2, and then we're adding 5. Now, axis of symmetry. Tell your neighbor what the equation of the axis of symmetry is. Okay, volunteer, what's axis of symmetry? Kendall? Okay, it is opposite of b over 2a, but we don't have it in standard form. Your axis of symmetry is always the same as the x value. So it's x equals 2. It'll always be the same. So if we go back to this graph, notice there's our x value, our h value. The axis of symmetry is the same equation. But Kendall, we're going to use that here in a minute, because now on number 3, we need to graph that. And it's not in vertex form. So to get it in vertex form, there are a couple ways to do it. Or you can just use the equation that Kendall just gave us. The axis of symmetry is equal to the opposite of b over 2a, which is equal to, well, here's b, negative 2 over 2 times, there's a. So it's negative 1. Not this negative 1. It's negative 1 because we did the math there. We also know the axis of symmetry and that x value is the same. So that means if I go ahead and try to find my vertex, well, I know one of my points now. It's -1. That's H. Emily. Okay, these two things are the same. What is my K value? We can't see it up here. How are we going to find it out? Matt? Okay, we plug it in. Okay, we're going to plug in H for X into this equation. So if I take that equation up there, I put -1 in for X. I end up with 1 minus 2 minus 1, or -2. Okay, so I have my vertex. I have my axis of symmetry. I can now graph it. Graphing it, not too bad. I just go in, I plot -1, -2. I draw in my axis of symmetry. I label both. And my A term is 1. So that means I'll go over 1 and up 1. In fact, this is a standard parabola, meaning if I go over 2, I'm going to go up 4. I go over 3, I'm going to go up 9. It's standard. Oops, I put that in the wrong spot. Unbelievable. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is not accurate. Okay? Tell your neighbor why this is a standard parabola. Okay, time's up. The A term is 1. When A is 1, it's our standard width parabola. Hey, you guys, this is incorrect, technically, and you're going to study more and more graphs that are called discrete and not continuous. Right now, you have a discrete graph here. It ends. How do I show that that graph goes on forever? Arrows. Start doing that on all your graphs, please. Okay? Otherwise, technically, you're inaccurate. Okay? Any questions there? Holy moly, man. That's some fun stuff. Mackenzie. Yes, our quiz is Friday. For sure. Okay, minimum and maximum values. Hey, if your vertex is here, it gives you a minimum value. If your vertex is here, your y term, your y is a maximum value. If it's here, it's a minimum. If it's here, it's a maximum. Tell your neighbor why that is.
Because if it's going up, then that's the lowest one.
All right.
Remember that.
Hey, why? Can someone explain to me why this is called a minimum and that one's called a maximum?
No pun intended.
Dallas? Okay. Another way of explaining? Yeah?
The minimum is the lowest point on that graph it's ever going to be, and the maximum is the highest point on that graph.
Good. You're going to measure the height of your graph, how high or low it goes, based on the y-axis. That's your measuring stick. Okay? My maximum point I'll ever have on a graph is at this point on this graph. The minimum point I'll ever have on this graph is right here. Does this graph have a maximum? No, it goes on in both directions, upward forever. There is no max. This one has no minimum. Okay? So when we're looking at this, this says the minimum value is f of opposite of b over 2a. In other words, find h, plug it into your equation, and that's going to give you your y value of your vertex, and that's going to be your minimum. Your maximum value here is f of opposite of b over 2a. So find h, plug it into your function, and get your y value of your vertex, your k term, and that's your maximum. Your domain, now domain means x. So if you forgot what domain means x, range means y. Domain means x, range means y. Those are terms back from algebra as well. Alphabetically, think of it this way. X comes before y, d comes before r. The domain, in other words, where my graph exists on the x-axis. In other words, what values for x could you put into your function and make it work? Well, this graph extends outward forever. It never stops extending outward. Therefore, all values of x will work, all real numbers. However, for y, does it extend up, down forever? No, it goes up forever, but it stops right here. So let's make, rather than saying my range is f is greater than what we call k, right? This is k. Okay, rather than saying that, let's pretend this is 1. Okay, this would say y, this graph, the domain of it would be y, or excuse me, the range would be y is greater than or equal to 1. Because it starts at 1 and goes upward. I was helping my daughter with this the other night. I said, hey, just take a piece of paper and scroll it on the graph. Once you get to where that, let's go this way. Once you get to where that graph starts existing, that is the beginning of your range. It starts existing at 1 and it keeps going up forever. Okay, same thing on this one. We're here, man, it's going on forever and it stops existing at, well, let's call that, pretend that's 3. So this would be y is less than or equal to 3 because it goes downward. Okay, thank you. All right, and so really what it means in terms of what we're doing, we're decreasing from the left of this. And then once we get to that point, we're increasing to the right. Here we're increasing until we get to that point, and then we're decreasing. Okay, so what I want you to do, I want you to try this problem right there. Number 5. Find the minimum value or the maximum value of A and B. Describe the domain and range and if it's increasing or decreasing. So this one opens up. How do we know it opens up?
Positive A.
Positive A. So this is going to have what type?
A minimum.
This will have a minimum. This one right here, open up or down?
Down.
Down. This has a maximum. All right. So now we have to find what the value is. How do we find the minimum value? Yeah, we have to find the vertex, which means we have to do the opposite of B for 2A to find the x value that we then can plug in to find the y value. So man, so that actually means opposite of B, negative 16 over 2 times 4 or negative 2. Okay? And then we plug that back in, so 4 times negative 2 squared, so we're plugging into this equation, plus 16 times negative 2 minus 3. So 16 minus 32 minus 3, or negative 19. So our maximum, or excuse me, our minimum value is negative 19. So if we're describing what's happening, well, the domain is all real numbers because it goes in all directions on the x-axis, in both directions forever. The range starts at negative 19 on the y-axis, and does it go up or down? Up. So it's greater than or equal to negative 19. Okay, so my graph is it's doing this, right? It's going down to negative 19. So it's decreasing till negative 19, from left to right until negative 19, and then it's increasing from left to right after negative 19. Okay, on the y-axis. Okay, on the x-axis, it's increasing, or excuse me, it's decreasing from left to right until you get to negative 2, and then it's increasing after negative 2. Okay. dude, there's one last thing I want you guys to try here, okay? And it talks about the core concept here. If you are in factored notation, how many remember what factored form looks like? You got parentheses? Okay, factored form says, hey, if this times this times this, if all these things add up to, or multiply together to make 0, then I know that this right here, I can set equal to 0 and solve. Okay, so let's do this in an example. Let's take this example, number 6. It says, graph the function, label the x-intercepts, vertex, and axis of symmetry. This right here, if this times this, if I know that this is an answer to a solution, if these are x-intercepts, I know that I can make my y be 0. I substitute 0 in for y, and I solve. So if I'm multiplying two things together to make 0, one of these two things has to be 0. We're not going to worry about the negative 1 out there. Okay, so what makes this 0? Negative 1. Okay, what makes this 0? Negative 5. That means my parabola, when I graph it, which we know opens up, or downward, excuse me. When I graph it, it's going to cross the x-axis at negative 5 and negative 1. Those are my x-intercepts. What's my vertex? Well, let's come back to that. What's my axis of symmetry? Has to be directly in the middle here. So it's the average of those 2 points. It's at negative 3. Okay? So my x value is negative 3. That's h. What's k? Well, we have to plug it in. Right? If we do f of negative 3, put negative 3 in. Negative 3 plus 1 is negative 2 times negative 3 plus 5, which is 2, times negative 1, which is 4. Negative 3, 4. That is my vertex. So if you're graphing this, all you really have to do is graph that much. I mean, yeah, you got to graph it on a grid, but if you put that point, that point, and that point, you're good to go. That's what all this is saying. It's saying take the average of those 2 pieces. Okay. We're going to pause there. Tomorrow. Okay, odds on this, evens are extra credit. Okay? Okay. Hey, odds, how many problems is that? It's about 9 problems. Okay? Very good.